Hello, welcome to next session. In this session, we will solve GATE 2017 Aerospace Engineering paper. Question 1 to question number 25 carry 1 mark each. The question number 1 is given the vectors v1 vector plus I plus 3j, v2 2I cap minus 4j cap plus 3k cap. The vector v3 that is perpendicular to both v1 and v2 is given by option A. Vector v3 is equal to vector v1 minus vector v1 dot vector v2 vector divided by magnitude of vector v2. Option B, v3 vector is equal to k cap. Option C, v3 vector is equal to v2 minus vector minus v1 vector dot v2 vector v vector by v1 vector magnitude of v vector. Option D, v3 vector is equal to v1 vector into v2 vector divided by v1 vector into v2 vector magnitude. Okay, so answer is option D, because v1 and v1 vector multiplied by v2 vector represents a vector which is in a direction perpendicular to both v1 and v2. And if we divide by this v1 vector by this vector by v1 into v2 magnitude, then it represents the unit vector in a direction perpendicular to the v1 and v2. So answer is option D. Okay. Next, the value of integral I curved x minus y dx plus x square dy with C the boundary of the sphere x is varying from 0 to 0 to 2, and y is varying from 0 to 2 is. So the given integral in the given integral is line integral, okay, or the curved integral. So that can be changed into area integral by using Green's theorem, and the Green's theorem is, we want to change the line integral or curved integral, then it is equal to curly psi by curly x minus curly pi by curly x is equal to dx dy. So here the psi is your this quantity with y coefficient of dy, and pi is, okay, so psi is x square and pi is your x minus y. Okay, so this is your so integration will be 2x, sorry, it will be its differentiation will be x differentiation will be 2x, and the differentiation will be minus y minus 1, so it will be 2x minus 1 dx dy, or it will be 2x plus 1 dx dy. Okay, and now this line integral has been changed into area integral. Now integrating these, so it will be 2x square by 2 or x square and plus x, and limits of x are 2 and 0. It is putting the limits to 0, so that is 4 plus 2 6 dy, and limits of integral this will be 6 dy to 0, and this will be 6y, integration will be 6y 2 to 0, or it will be 12. So answer is 12. Next, let Vt be a unit vector that is a function of parameter t. Then vector v dot vector dv by dt is dash dash. So let Vt is your r sin omega t, and r and omega are constant, and now v is the function of t only. Okay, so dv by dt is your r omega sin pi by 2. So sorry, dv by dt differentiating it r omega cos omega t, and now cos omega t can be written as pi by 2 plus plus omega t. Okay, so this can be written like this. So now these two are perpendicular to each other, vt and dv by dt are perpendicular to each other, so the angle between them is pi by 2, and their dot product is magnitude of v vector magnitude of dv by dt and cos pi by 2. Okay, and as theta is your pi by 2, the angle between two vectors is cos pi by 2, that is 0. So dot product is given by given like this: magnitude of this vector, magnitude of this vector multiplied by angle of cos of angle this. Okay. So this is 0, this is 0. Okay. So answer is 0. Next, the eigenvalues lambda n and the eigenfunction un of the Sturm Liouville problem d square y by dx square plus k square lambda y is equal to 0. X is varying from 0 to 1, y 0 0 and y 0, y 1 is 1 are given by lambda n square pi square un x sin lambda n x n is equal to 0 plus minus 1 plus minus 2. Option B, lambda n is equal to n square pi square by k square u x sin kx pi x x 0 plus minus 1 plus minus 2 0. C, lambda n is equal to n square pi square by k square un x sin pi n pi x n is 0 plus 1 plus minus 1 plus minus 2. Lambda n is option D, lambda n square pi square un function of x sin n pi x n 0 plus minus 1 plus minus 2 0. So d square y by dx square plus k square lambda y is equal to 0. Now solution of this equation is let the solution of this equation is a cos root of this into x plus b sin root of this into x. Okay, and the boundary conditions are x is equal to 0, y is equal to 0. Okay, so if we put x, these boundary conditions are given: x is 0, y is 0. If we put x equal to 0, then a will be 0. Okay, this quantity is 0 and this quantity is 1. So this quantity is 1. So this a will be 0. Okay. Now the equation becomes because this factor has been made 0. Now the equation is this. Okay. So b sin root k square lambda x. Okay. So the second condition is when x is 1, y is equal to 0. Now putting x is equal to 1, we have y is equal to 0. So b sin root k square lambda is equal to 0. So b is not equal to 0, because if b is 0, then this whole equation will become 0. So b is not equal to 0. So putting sin root k square lambda is equal to 0, we get k square lambda is equal to n pi, or k square lambda is equal to n square pi square, and n is 0. Now lambda is just n square pi square by k square, with n being 0 plus minus 1 plus minus 2 plus minus 1. And the function is given by this factor, is sin k square lambda x. Okay. So this is sin n pi, k square lambda is root k square lambda is n pi, so n pi x. So answer is option C.